You train a 10-class object detector, and it works great, except for two classes that look almost the same. So what do? Do you make the detector bigger, add a new second model, or something else entirely? Let me save you months of pain. What you're dealing with is a fine-grained recognition problem. Your model handles 8 classes just fine, but for the remaining 2, the differences are tiny. You're asking the model to notice subtle details that even humans struggle with. Now, should you make the detector bigger? Absolutely not. A bigger backbone rarely solves the fine-grained problems. You get diminishing returns without addressing the root cause. Before we do anything else, make sure you have tried 2 things. First, use augmentation that force models to focus on details. That's high-intensity random cropping, zoom in, and more close-range texture exposure. Second, upweight or upsample cases where the model confuses the 2 classes. So use hard examples more number of times during training. This is called online hard example mining. If augmentation and hard example mining do not work, you have 2 options. The first is simple and very effective. Simply add a fine-grained classifier for the 2 classes. For the object detector, you merge these 2 classes and train a detector on 9 classes instead of 10. Then use a tiny model like ResNet 18 or EfficientNet to separate the 2 confusing classes. That's it. It's modular, it's clean, it works extremely well. The second option is better feature engineering and loss function. This is often more powerful than the first option, but this also requires a lot more skill. For example, you could integrate channel and spatial attention like convolutional block attention module, CBAM, into the detector's backbone. This pulls the model's attention towards the tiny discriminative regions that separate the 2 classes. You could also add triplet loss or contrastive loss to the classification branch. This pushes the 2 classes apart in the feature space and pulls the same class examples tightly together. This is how face recognition separates nearly identical faces. So here's the real answer. Just don't make the model bigger.